All right, so let's see what we can do in section 6 here, where we're talking about words problems, story problems, and it looks like we're going to be using quadratics here. Let's read number 1. Number 1, a square has sides measuring x plus 3. The area is 49 square units. We're supposed to find x. All right, so a square has side, well, that's pretty important right there, being a square, right? Each side is x plus 3 units long. The area is 49. What I've always done with the story problem is if I can, I'm going to draw a picture. Since we're talking about a square, let's draw a square. And then it says that each side is x plus 3 units long. So each side we have that, right? It says the area is 49 square units. So A is equal to 49. Well, how do you find the area of a square? Well, isn't it length times width or side squared, whatever? You're going to take this times this. So we've got x plus 3 times x plus 3 would be equal to 49. And now we have to solve this. Well, in order to get this thing solved, I've got to get rid of the parentheses here. So what am I going to have to do there with x plus 3 times x plus 3? If you're thinking FOIL it, you are dead on right. So let's get rid of these parentheses, because you can't do anything with an equation if there are parentheses, right? So we're going to have to clear the parentheses. So x times x is x squared. 3 times 3 is 9. We have 3x, and 3x is 6x equals 49. Now we've found so far that all of our and this is quadratic, right? As soon as you have an equation that has x squared in it, we're talking a quadratic, regardless of what it says up here. Think about where you are and what you're doing here. We have an equation, x plus 3 equals 49. As long as you have an equation, you're solving. You solve equations, right? Always solving equation. All right, so here we have x squared plus 6x plus 9. Now, this is quadratic, so since it is quadratic, there are several ways we could solve this equation. We could do so by graphing. I don't think we're going to do that, right? I don't even have any graph paper here with me. I could factor it. I could complete the square. We talked about that a little bit. We're not going there. I suppose I could use the quadratic formula. This works every time. This is fast if it can be factored. Either way, if I'm going to be factoring or using the quadratic formula, what do you need on the right side of the equal sign? We're going to need 0. So what I'm going to have to do is subtract 49 from both sides. So now I have x squared plus 6x minus 40 is equal to 0. So I guess it looks like this is probably going to be factored. I could use the quadratic formula. Let's see if we can factor this. We have, since it's starting with an x squared and not a number times, since a is equal to 1 here, this looks like it might be easily factored. I'm going to have an x here and an x here. I have to have plus and minus. It looks like 10 and 4, right? Positive 10 and negative 4. Well, what does that mean? That means x plus 10. Remember what we were doing before? X plus 10 is equal to 0, or x minus 4 is equal to 0. When I subtract 10 from both sides here, I get x is equal to negative 10. Now, my question is, would that work on a square? If I were to put negative 10 here, wouldn't I have negative 10 plus 3 is negative 7? I mean, sure, negative 7 squared is 49, but could we use negative 10 here for the dimension of a square? No. So let's try this one. How about adding 4 to both sides here? x is equal to 4, that looks like it's more reasonable. Because if I put 4 here, 4 plus 3 is 7. 4 plus 3 is 7. 7 times 7 is 49. So x must equal 4. Number 2. The area of the rectangle shown is 75 inches square, so this area is 75. Find the dimensions. Now this one says find the dimensions. Up here it said to do what? Find x. Always make sure you're concentrating on what it is you're supposed to do in a problem, right? So how would you find the area of any rectangle? We're going to take the length times the width. So I'm going to take 2x times x plus 6, and I'm going to get 75. Again, equal sign. That means you're solving this equation. What can we do to solve this equation? Well, the first thing I need to do is eliminate any parentheses. How am I going to do that in this case is by using the distributive property. So 2x times x is what? 2x squared. 2x times 6 plus 12x is equal to 75. Well, what kind of equation is this? Well, being x squared, we have a quadratic. Well, what does that mean to do? What do we need to do now? Well, it means we need 0 on the right side. Whether or not I'm going to factor or use the quadratic formula, I need 0 on the right side. So how can I get 0 here? Well, by subtracting 75. So I'm going to have 2x squared plus 12x minus 75 is equal to 0. Now the decision is, do we factor this or do we use the quadratic formula? Ready for another trick here? Not a trick, I mean it's a fact here. I'm going to show you a way to see if a polynomial in the form of ax squared plus bx plus c, can this be factored? Here's the test. Take the leading coefficient 2 times negative 75, and what do you get? Negative 150. Write down all the pairs of factors of negative 150, starting with positive 1. There's 1 in negative 150, 2 in negative 75, 3 in negative 50, 4 doesn't go into 150, 5 does, 5 goes in, was it negative 30 times, right? 6, negative 25. 7 does not work, 8 does not work, 9 does not work. How about 10? 10 and negative 15. Are there any other combinations of pairs of factors of 150? I think that's it, isn't it? Now, do any of those add up to positive 12? Can we get 12 out of any of those? Doesn't look like it. Or even if we change the signs, make all these negatives and all these positives, is there any way we're going to get positive 12 out of those? Since the answer is no, this polynomial cannot be factored. So we're going to have to use the quadratic formula. So I always write down the quadratic formula second. First, I'm going to write down a is equal to 2, b is equal to 12, c is equal to negative 75, and x equals negative b plus or minus the square root of b squared minus 4ac, all of it over 2a. Equals negative 12 plus or minus the square root of 12 squared is 144 minus 4 times 2 times negative 75. All of it over 2 times 2. Negative 12 plus or minus the square root of 144, a double negative will make it a plus sign. 8 times 75 is what? 600, all of it over 4. So we're going to have negative 12 plus or minus the square root of 744 over 4. Well, take the square root of 744, you get about 27.3. So your answer is either going to be negative 12 plus 27.3 all over 4, or negative 12 minus 27.3 all over 4. Now we are talking again about the length of a rectangle, dimensions of a rectangle, length and width. Would it make sense to take negative 12 minus 27.3? We're talking about negative 40 there, just about right. Negative 40 divided by 4 is negative 10. Would that work for the dimensions of a rectangle? No. So this one's out. So I'm going to take negative 12 plus 27.3, and I'm going to get 15.3. And I'm going to divide that by 4. This is just an approximation here, but 15.3 divided by 4. And if we're talking, rounding that off to the nearest tenth, we're talking 3.8. Again, an approximation, close enough for what we're working with here. So what did I say, 3.8? 3.8 plus 6 would be 9.8 for this side, and 2 times 3.8 would be 7.6 for this side. And there you have it. That's how you would solve those two. In number 3, the area of this rectangle is 112. Find the dimensions of the rectangle. Well, again, we're talking area here. So how do you find the area? And do make sure that when you read these problems, circle keywords and expressions like area as opposed to perimeter and area. Write down the formula if you need to. Length times width, right? The area is 112. It says to find the dimensions of the rectangle, which means find the length and find the width. All right, so here we go. Length times width. We're going to be taking 2x plus 4 times x plus 3, and when you do that, you get 112. Well, again, going back, well, this is an equation, right? And don't we solve equations? Sure. So how do we solve an equation? Well, we have to clear any parentheses. That's always number one on the list of things to do when you're solving an equation. So we're going to FOIL this. So 2x times x, 2x squared. 4 times 3, positive 12. 4x and 6x are 10x. And that equals 112. Well, again, quadratic, because of the x squared, I'm either going to use the quadratic formula or I'm going to try to factor this. I'm surely not going to be using graphing to solve this. So what do? Well, you need 0 on one side, so let's subtract 112 from both sides. So I'm going to have 2x squared plus 10x, 12 minus 112 minus 100 is equal to 0. What's going to make this a little bit easier to factor? If it can be, right? Let's see if we can factor out that 2, and that most surely we can here. So I'm going to have 2 times the quantity x squared plus 5x minus 50 equals 0. Well, as we've discovered earlier, we can throw out that 2 because it'll never be equal to 0. So the 2 gets eliminated. So I need to factor this. So it's going to be 2 sets of parentheses. X times x will get us the x squared. I'm going to need a plus and a minus. 50 and 5. Well, hey, how about 10 and 5, right? But I need more pluses here. So plus 10 and minus 5. So either x plus 10 is equal to 0 or the x minus 5 is equal to 0, right? Well, in this case, the first case, we get x is equal to negative 10. Is that going to make sense? No, I think not. How about x is equal to 5? Would that make sense for the dimensions of a rectangle? Sure it would. So let's plug in 5 for each of these x's. 5 plus 3 would be equal to 8. 2 times 5 is 10, plus 4 would be equal to 14, and there are the dimensions of your rectangle. Find two consecutive odd integers whose product is 255. Now, we were doing these last semester, but weren't we working with sum before? It was the sum of two consecutive odd integers, right? Well, this is product this time. So, well, we need to set this up a little bit differently in that, well, what's going to be the same about setting this up and what's going to be different about setting this up. A couple of things here, right? Two consecutive odd integers. Well, if you recall, when we set up odd integers before, we would say, let x equal the first odd integer. You have to define your variables. How would we find the next consecutive odd integer? Well, we'd have to add 2 to it. Remember that? So x plus 2 would be the second odd integer. Now, before, when we would set up the equation, we would go x plus 2 equals whatever, right? But that's when we were talking about the sum. This is product. What does product mean we do? Right. We're going to be multiplying here. So we're going to multiply these two things together. So how about x times x plus 2 is 255? And again, you have an equation. How do you solve an equation? Clear the parentheses. Distributive property, right? X squared plus 2x is equal to 255. Now you have a quadratic. So what do you do to solve a quadratic? Well, you need 0 on one side. So let's subtract the 255 from both sides. So x squared plus 2x minus 255 is equal to 0. Well, now you have a quadratic that you're going to solve. You got the 0 on the right side. We're either going to factor it or use the quadratic formula. Well, it looks like we can probably factor this. So, well, we know we're going to have x times x. We have to have a plus and a minus. Now, what two numbers can we multiply together to get 255 that are two numbers away from each other? It's going to be like 1 and 3, 3 and 5, 5 and 7, 7 and 9, 9 and 11. What two factors, what two numbers, what two consecutive odd integers would equal 255? Well, how about 15 times 17? Only we need positive 17 and negative 15. So, now think about what's happening here, class, because when you have x plus 17 is equal to 0, isn't x equal to negative 17? Is that an odd integer? Sure it is. If negative 17 goes here, what's negative 17 plus 2? Negative 15, right? So there's one set of possible answers. But look, what else is going to happen? If x minus 15 is equal to 0, don't we get x equals 15? Isn't that a possible answer also? Sure, x could be equal to 15, which means x plus 2 would be equal to what? 17. And there's another set of possible answers. So actually, remember, we're going to be, because it's a quadratic, we're going to have two answers here. There are going to be two x's, negative 17 and 15, and then there are going to be two x plus 2's, x plus 2 equals negative 15, and x plus 2 here equals positive 17. So there's actually two sets of answers on this problem. Number 5, a football is kicked into the air. The height, h, of the ball at any given time, t, is given by the equation h equals negative 16t squared plus 50t plus 5. How long is the football in the air? Okay, what is this question saying? All right, so here's the ground, right? And for any of you football fans in there, what we're talking about here is what? How long is it in the air? Hang time, right? So here's the ball being kicked into the air. All right, not a very good looking football, but think about the path that it's going to be taking. It's kicked into the air, and eventually what's going to happen if it's not caught? Yeah, we're going to have it hit the ground, and what's the path that this thing takes? A parabola. Here's the quadratic equation, a quadratic formula that shows you the height of that ball. There's your quadratic that shows the height of the ball. Now, here, this is key right here. How long is the football in the air? Well, think about this. When is it not in the air? When it's on the ground, right? What's the height of the ball when it's on the ground? 0, right? So 0 goes in for the h here. So you actually have the equation negative 16t squared plus 50t plus 5 is equal to 0. So now you have a quadratic. You either are going to factor this or you're going to use the quadratic formula. I would use the quadratic formula. Go ahead and see if you can solve this and tell me when this thing is going to be hitting the ground. Go ahead and pause the video and come back in a few minutes. As for number 6, a baseball is thrown into the air. The height of the ball is at any given time t is given by the equation 32t minus 16t squared. How many seconds before the ball hits the ground? Again, when it hits the ground, what's the height equal to? 0. So we're going to put that in here for the height. So 0 is equal to 32t minus 16t squared. I like to have the 0 on the right side, so I'm going to have 32t minus 16t squared is equal to 0. Looks like we can factor this one. So let's factor out the GCF of 16t. So I'm going to have 16t times the quantity, 2 minus t is equal to 0. So either 16t is equal to 0 or 2 minus t is equal to 0. When I solve for t here, dividing both sides by 16, t is equal to 0. So at 0 seconds, the ball's on the ground. Yeah, that one didn't make a whole lot of sense. But anyway, I think what they're asking for is to solve this one. When we subtract 2 from both sides, I get negative t is equal to negative 2. Dividing both sides by negative 1. The ball will be on the ground in 2 seconds. Not a very hard ball being thrown there. Number 7, a little rocket science for you. A rocket is launched into the air. The height h of the rocket will be h equals 1600t minus 16t squared. When will the rocket be 14,400 feet high? Well, let's draw a little picture here. Here's the ground. Here's our rocket. All right, not a very good rocket. So it's going to go up, parabola. It's going to be coming back down. Now here's the situation here. There are 3 different scenarios we need to consider. Now, it could be that it reaches 14,400 feet twice, once on the way up and once on the way down. Or it could reach 14,400, just once. It reaches 14,400, drops back down safely to the Earth. Or what's the other scenario? It could be that 14,400 is way up here, and it may not reach it at all. So we have three things to consider here. Either way, we're going to put 14,400 in for h because that's the height. We can figure out what t is when we put the height 14,400 in for the h. So 14,400 is equal to 1,600t minus 16t squared. Well, that looks like a mouthful. Well, either way, it's an equation, right? And either way, I'm going to need 0 on one side. So I may as well subtract my 14,400. So let's get 0 on this side. Minus 14,400. Minus 14,400. Well, let's see now. I'd like to have my 0 on the right side. So I'm going to take this and move it over here. And I'm going to take what's on the right side. I'm going to take this stuff and put it over here. Now, I like to have things in descending powers. It's just being meticulous, right? So I'm going to take my negative 16t squared. This one right here, it's going to come first, negative 16t squared. Then I'm going to take this one and put it next. That's a positive 1600t. And then minus 14,000. I'll get it right here in a minute. Minus 14,400 equals 0. I'm wondering if there's a GCF here. What do you think it might be? Do you think 14,400 might be divisible by 16? And since the first term is negative here, I'm not just going to factor out the 16. I'm going to try factoring out negative 16 and see what happens. So that means I'm going to have negative 16 times the parentheses. All right, t squared because the negative 16's cancel. 1,600 divided by 16 will be negative 100. And then negative 14,400 divided by negative 16, and we're going to get positive 900 equals 0. All right, so now we have a quadratic. I'm going to be able to throw out the negative 16 because it'll never be equal to 0. Now all I need to do is factor what's left over. It looks like that can be factored. See now, two sets of parentheses, t and t. I'm going to need two minus signs. Oh, this is an easy, 90 and 10, right? So t minus 90 equals 0. T is equal to 90 seconds. T minus 10 is equal to 0. T is equal to 10. Ha! Look at this. This rocket reaches 14,400 twice. Once at 10,000. Excuse me, at 10 seconds. So it takes off, and 10 seconds later, it reaches 14,400. Keeps going up, and after a while, it comes back down, and then at 90 seconds after liftoff, it hits 14,400 again. So there you go. It does reach 14,400 twice at 10 seconds and 90 seconds. And if you have any questions on this, we can surely talk about it in class. Until then, have a great day.